Hello student. So this is the new chapter of maths, and the chapter is triangle. This is basically congruency of triangle. So first of all, we have to understand what is congruency. We can make two figures congruent, such as take two squares, each of side 2 centimeter, 2 centimeter. Take another square, 2 centimeter, all sides are 2 centimeter. If we take this square and put it above this, then all these sides will completely cover these four sides. That means these two squares are of exactly same size. So then we call these two squares are congruent, and the symbol of congruent is an equal sign, and above there is an arc. Okay. Similarly, we'll see some more congruent figures. Consider two triangles of radius 3 centimeter each. This is also a triangle of radius 3 centimeter. If we place this triangle above this triangle, so then the circumference of this triangle will touch the circumference of the second triangle. So again, these two triangles can be called congruent. Similarly, if we take an equilateral triangle means whose all the sides and the angles are equal. Consider this as 5 centimeter, 5 centimeter, and 5 centimeter. The angles are 60, 60, and 60 degree because all the three angles are equal. Take another triangle, same 5 centimeter, 5 centimeter, 5 centimeter. If we place this triangle above this triangle, again it will cover all the three sides. So these two triangles are also called congruent. So these are some examples of congruent figures. So in case of triangle, we have different types of triangle: isosceles triangle, scalene triangle, and to prove their congruency, it is very difficult work. So we have placed some rules to prove two triangles are congruent. So we will first learn what are the different types of congruency. So types of congruency. So the first one is side angle side. In short, we said it SAS, side angle side. So if in two triangles, take first one as ABC and second one as PQR. Okay, and consider the side AB is equal to side PQ, side BC is equal to side QR, and if angle A is equal to angle Q, then we can say that these two triangles are congruent. Right? Because the respective two sides are equal, and the angle between these two sides is equal to the angle between the two sides of the other triangle. So how we write in triangle ABC and triangle PQR? So in ABC we will write AB is equal to, in PQR we will write PQ. Next, angle B is equal to angle Q. And lastly, we can say BC is equal to QR. So BC is equal to QR. So if we find 3 points equal, then we can write therefore triangle ABC is congruent to triangle PQR by side angle side. By looking at the order of these 3 points, we cannot say these two triangles are equal. We cannot determine the criteria by looking at the order of writing these three equalities. We have to see a triangle, and here we can see that in between two sides one angle is equal. So this is side angle side. Okay, so we will come up to the next type of congruency, and this second type is called angle side angle. So from the name only we can see that in between two angles one side has to be equal. Okay, so we will take two triangles ABC, PQR. So if AB is equal to PQ, angle A is equal to angle P, and angle B is equal to angle Q, let's see, in between two angles there is a side AB. So this will be triangle ABC is congruent to triangle PQR by angle side angle. So angle then side then angle. Between two angles there has to be a side, then only we can say angle side angle. Third type is angle angle side. So after two angle there has to be the side. So consider two triangle ABC, D, E, F. So if angle A is equal to angle D, angle B is equal to angle Q, and BC is equal to EF, then you can see that after two angles the side is coming. So this is angle angle and side. Okay, here we can say angle angle side congruency. The fourth one is side side side. So this is the very simple. All the three sides of two triangles has to be equal. ABC, PQR, where AB should be equal to PQ, BC is equal to QR, and AC is equal to PR. Then we can say that these two triangles are congruent by side angle side. Okay, all the three sides are equal to the corresponding three sides of the other triangle. The last one type of congruency is RHS. So R stands for right angle, H stands for hypotenuse, and S stands for side. So by the name only we can make the idea that the two triangles has to be a right angle triangle. A, B, C, P, Q, R. So here angle P is 90 degree, here angle Q is 90 degree. So automatically these two angles are equal because these two are 90 degree each. And second is what? Hypotenuse. So the hypotenuse of one triangle has to be equal to the hypotenuse of other triangle, and from the other two sides any one side should be equal to the remaining any one of the other two sides. Consider here the other side is QR. So right angle, then hypotenuse, then any one side. So this type of congruency is called RHS. Now we'll apply this, then you will understand more. Okay. We'll start with exercise 7.1. So here you can see that in the first question, see the diagram. A line is there, AB, C is a point, and D is a point below AB. Above AB there is one triangle, and below there is another triangle. It is given that AC is equal to AB, and these two angles are equal. Okay, it is given in the question that the line AB bisects angle A. Therefore, the angle A is divided into two equal angles. We will name it as angle 1 and angle 2. So in this type of question, we have to write first given. What is given? AC is equal to AB. So first AC is equal to AB. Second point is AB bisect angle A. AB bisect angle A. To prove, you are asked to prove that ABC is congruent to ABD. And let's see what is given next. What can you say about BC and BD? In exam, you will be given that prove that these two sides are equal, BC equal to BD. So what we have to prove, we will write in two proof. So the first proof is prove that triangle ACB or ABC is congruent to triangle ABD. The second proof is BC is equal to BD. So we'll start the proof. First of all, we'll write first proof. We'll write the name of the two triangles. So the name is in triangle ACB and triangle ABD. So what are the 3 points? We have to write 3 points. So see, in upper triangle AC and in lower triangle AD, these two sides are equal. So AC is equal to AD. This is given. Next, you can see angle 1 is equal to angle 2. Angle 1 is equal to angle 2, where we have gotten this, since AB bisect angle A. Okay, and the third point will be, you can see this side AB is common to both the triangles. Both the triangle has this side AB. So we'll say that AB is common. So 3 points we have got equal. Therefore, triangle ACB is congruent to triangle ABD by which criteria? We have to see any one triangle. See, AC we have taken this side, AB we have taken the other side, and in between these two sides the angle is there. Okay, so this is side angle side. The side angle side congruency. So first proof is over. So second proof. Now when two triangles are equal, we can take other remaining sides equal. Okay, we can take the remaining sides equal only after proving that these two triangles are congruent. So we can take BC of the first triangle is equal to BD of the second triangle, and we have to write CPCT. So what CPCT stands for? Congruent parts of, corresponding parts of congruent triangles. So after proving two triangles congruent, we can take the remaining sides equal of each other. Okay, so the first proof is completed here. You write down in your copy. I will also give the screenshots of this in the group. So now coming to question number 2. So see here, there is a quadrilateral. In the second question, take your book by your side. You will see a quadrilateral is given A, B, C, D. In this quadrilateral, it is given that AD is equal to BC. Okay, angle BAD, this angle is equal to angle ABC. This angle, these two angles are also given equal. You have to prove that this triangle ABD is congruent to triangle ABC. So we have to join AC. These two triangles are congruent. And second proof is BD is equal to AC. And the third proof is ABD. ABD means this angle has to be equal to BAC, this angle. Okay, so we'll start with given. It is given that AD equal to BC, AD is equal to BC. Second, it is given this angle A, we will write BAD, angle BAD is equal to angle ABC, ABC. And to prove, we have to prove 3 points. The first one is triangle ABD is congruent to triangle BAC. The second proof is BD is equal to AC, and the third proof is angle ABD is congruent to angle BAC. So we'll start the proof from number 1. We'll write the name of the two triangles which we have to prove equal. So in triangle ABD and triangle BAC. So what are the 3 points? First point is, in this triangle AD and in this triangle ABC, BC, these two sides are equal. So AD is equal to BC, and this is given here. It was given. Second proof, you can see the side AB, is common to both the two triangles. So we will write AB is common. And the third is angle A of this triangle is equal to angle B of second triangle. So this is angle DAB is equal to angle ABC. This is also given. So therefore triangle ABD is congruent to triangle BAC by which criteria? Again, you have to take any one triangle. See, in this triangle AD was considered, AB we have taken, and this angle is taken. So between two sides an angle is taken. So this is side, angle, side. SAS. First proof is over. So when two triangles are congruent, we can take CPCT. So in this triangle BD and in this triangle AC, we can take this equal because these two sides are the parts of the two congruent triangles. So we will write BD is equal to AC CP CT. Second proof is also done. Third is ABD. Now see, ABD belongs to again this triangle, and BAC belongs to the second triangle. So again we can take another CPCT. We can take as much CPCT as we want unless these two triangles are proved congruent. So the third is also coming in CPCT, and angle ABD is equal to angle BAC. This is also CPCT. Okay. So this sum is also done. So now coming to question number 3. So the third question, in the third question there is a line name is AB, and at the point B there is a perpendicular BC, and at the point A there is another perpendicular DA, and this CD is joined. Now CD intersect AB at the point O. You have to prove that these two triangles are congruent. You are asked to prove that CD, this line CD, bisect AB. Bisect means these two parts have to be equal. You have to show that these two parts are equal. So we will first make these two triangles congruent, and in CPCT we will take these two sides equal. So we will start with given. What is given? This is perpendicular upon AB, and this is also perpendicular. BC and DA are perpendiculars upon AB. To prove also these two sides are also equal. BC is equal to AD. This is also given. We have to prove that CD bisect AB. Now we'll start the proof. So first of all, we'll write the name of the triangles. In triangle, this is BCO and triangle DAO. So what are equal? Here BC is equal to DA. This is given. Next, in this triangle, angle B is 90 degree, and in the second triangle, angle A is 90 degree. So angle B is equal to angle A. Why? 90 degree each. Third point, you have already learned in chapter 6 that whenever two lines intersect each other at a point, then the vertically opposite angles are equal. You can apply this here. These two lines intersect, so this angle will be equal to this angle. These are vertically opposite angles. So angle BOC is equal to angle DOA, vertically opposite angles. So therefore triangle BCO is congruent to triangle DAO by which criteria? So now we have to take one triangle and see which parts we have taken. So here we have taken BC, this is a side. Here we have taken an angle, and here also we have taken an angle. So after two angles, this side has come. So angle, angle, side. So this will be angle, angle, side. So when these two triangles are congruent, we can take CPCT. So here we will take BO is equal to AO, CP, CT, corresponding parts of congruent triangles. So therefore CD bisect AB. This is over. Coming to the next question, question number 4. See here, two lines are given. This line is L, this line is M, and these two lines are parallel. Another two parallel lines are given. This line is B, this line is Q, and these two lines are also parallel. Now these two pair of parallel lines intersect at 4 points. These 4 points are A, B, C and D, and we have joined AC. These things are given. So what is given? L is parallel to M. This line name is L and this line name is M. So L is parallel to M. Second is P is parallel to Q. To prove, these two triangles are congruent. Triangle ABC is congruent to triangle CDA. So we'll start the proof. First, we have to write the name of these triangles in triangle ABC and triangle CDA. So what are the 3 points which are equal? You can see that this side AB is common to these two triangles. So first we will write AC is common. Next, we know that when two lines are parallel and these parallel lines are intersected by a transversal, then these two angles are alternate angle, these two angles are also alternate angles. Okay, so we'll apply these things here. These two lines are parallel and this is the transversal. So this angle is equal to this angle, alternate angles. We'll name this is 1, this is 2. So in ABC we have angle 2, we'll write angle 2 is equal to, in ADC we have angle 1, so angle 1. Why these two are equal? Because they are alternate angles. Next point, again if we consider these two parallel lines and these are transversal, then this angle will be equal to this angle. We'll take it as 3 and this is 4. So in this triangle we have 3 and in this triangle we have 4. These are also alternate angles. So therefore triangle ABC is congruent to triangle CDA. By which criteria? We have to take one triangle. You see in this triangle this angle is taken, this angle is taken and this side is taken. So in between two angles one side is there. So this is angle side angle. Okay. So question number 4 is also done. Next is question number 5. Here one angle is given first. Okay, angle A, and this angle A, this angle is bisected by a line L. This name is L. So since it bisects the angle, so these two angles are equal, we will name it as 1 and 2. There is a point B on this line and from B two perpendiculars are drawn. This is one perpendicular and this is another perpendicular. This is BP and this is BQ. You have to prove that these two triangles are congruent, first proof. Second, you have to prove that these two perpendiculars are equal. Okay, only these two proof are there. So first we'll start with given. What is given? Line L. L bisect angle A. This line is bisect angle A. BP and BQ are perpendiculars. To prove, first one is triangle APB is congruent to triangle AQB. Second one is BP is equal to BQ. Okay, so we start the proof. Number one, we'll write the name of these two triangles. In triangle APB and triangle AQB. So in these two triangles, which sides are equal? See, in these two triangles, first the easiest is this common side. AB is common to both the triangles. We'll write AB is common. Second is angle 1 is equal to angle 2 because this was the bisector of angle A. Angle 1 is equal to angle 2. Why? Since L bisect angle A. Third is this is 90 degree and this is also 90 degree. So this angle name is BPA. Angle BPA is equal to this angle name is AQB. AQB. Why equal? 90 degree each. So we have got 3 points. Therefore, triangle APB is congruent to triangle AQB by which criteria? We have to check by looking at one triangle only. Look at this triangle. This is angle. Again, this is angle, and then comes the side. So okay, this is angle, angle, side congruency, AAS. So first proof is over. Second proof, BP is equal to BQ. So BP is in this triangle and BQ is in this triangle. So this two becomes CPCT. BP is equal to BQ, CPCT. So this proof is done. I'll upload the photos in the group. You write down in a class or copy and practice these sums properly.